Valeo, Chennai. He worked as technical architect in advanced driving assistance system in research and development wing of Tech Mahindra, Bangalore. Sir worked as a lead technical analyst in Humasys Technology Private Limited, Kolkata. He also worked as assistant professor at Gandhi Institute for Technology, Bhubaneswar, Odisha. He received PhD degree from Indian Institute of Technology, Kharagpur. He has more than 15 years of research and industrial R&D experience. He received more than 10 awards from IEEE, STPI, MOE, MIT, CSE, and others. He is the IEEE senior member. He has published many research papers in reputed journals and conferences. He published around 21 utility patents, 1 design patent, and 7 copyright granted in the field on invention in ADS, HMI, AICV, AIML, and BME. His current research interests include computer vision, HDI, graph neural network, and autonomous system. He delivered many invited talks and chaired many sessions in many national and international conferences. He acted as a reviewer in many reputed journals of IEEE, SCM, Elsevier, and Springer. So with this short bio, I once again welcome sir to our program, and over to you, sir.
Thank you, Dr. Manjuvala ma'am. This is not short intro; it's a long intro, in fact. So I thought it would be very, shortcut. Anyway, thank you so much, ma'am. Before I proceed this today's session, first of all, I'm privileged, that invitation by Department of Computer Science, Engineering, and IT Warangal. It's I'm happy that it's a session and where I can take part as a speaker or even also as a participant. I learn many things from the participants, those who are present over here. And this is not a fast interaction maybe with the faculty members, because though I was working as a faculty itself, I think almost 10 years back. So I know that how to, to talk to the colleague, those who are faculty community all together. And also there is a, a lot of learning from faculties as well. If it is a, if it is a kind of, the session where all together we can learn many things, the advanced technology, though the topic itself calls, smart computing, how the optimization is going to be impact on your next generation technologies. So I'll discuss on those points because my background, madam already mentioned that I have worked last 10 years almost in ADAS, the verticals in terms of in-cabin sensing, in terms of, the perception system through different modality. So I'll discuss on those points as a case study. Before I proceed, if any participants, interact with me regarding any particular discussion, please, we can start right now, because you might have seen some of the sessions already, delivered by the experts, right? So far, the last session I mentioned. So in discussion, before I proceed, if you try to, align those discussions already happen and how to align to this particular session. And if it is, I learn from you because I do not know what already covered last sessions. So if something is new to me, I love to learn from you all. Then I'll try to, cover up the things which are prepared to, deliver today's session. So, I think any particular, any topic or anything you try to, map those discussions with it, the today's topic. Okay, so I don't know whether it is already aligned to this topic or not. So I'll try to map the discussions as per the particular FDP agenda. I think the FDP is already well designed, and really it is very good, very interesting to interact the faculty community on the recent advanced technology in terms of next generation computing for smart system development, and how the optimizing the techniques need to be adopted nowadays. This is very challenging for all of us, not only for the faculty community, the industry peoples, the research community, all are working on together. It's a kind of, the collaborative effort we can put together to optimize those, the next generation computing for smart system development. I do not know how far you understood that part, but today's session will be more towards that, the ADAS use case, how ADAS means autonomous driving, or you can say intelligent driving, or you can say driving assistance system. You can say anything on the particular angle. So my focus will be mostly to touch upon that. The case study is mostly on ADAS. It is the expertise of my field. So I'll not to jump to all particular domain where I don't have the grip at all. I know that how the computations happening in the ADAS system in terms of advanced technology with the computation, optimization, and altogether perception. So I'll touch on that points. So before I share the topic, the today's topic will be the optimizing next generation computing for smart system development, a case study of ADAS. So I will proceed with some particular question and session. I know that it is the last session. Still, people are to hurry to get the certificate of the completion, that as a FDP complete certificate, and they'll produce to their respective institutes or organization that they have attended the program successfully. They learn many things virtually. So I don't know, but my point is that I'll put some kind of the questions to the participants. Though I love to learn from you through this question. So what is your thought on that? How you feel that next generation technology will be in advanced stage? What type of challenges, the criticality we are going to face if it is in terms of advanced technology, computation, perception, and optimization? Anyone, please, either you switch on camera, or you do not required to switch on camera. Please speak. I believe there is 140, 145 participants all join. So if any particular the participant love to interact with me, I'll also interact with you. Yes.
Sir, I hope that hereafter there will be no physical work except the brain. Nothing has to work.
Okay. Okay. Thank you, oh ma'am. Any other point?
Hello, sir. Good evening.
Yeah, hi. Good evening.
So, sir, my point of view on that is like if we manage to control the technology, we are the humans, we are the core of that technology. So we are technology is because of us, not we are because of that. So if we are managed to control our basic needs or basic things by our own, then I think so it is best thing to use that advanced version of technology. But if we completely rely on the technology, then we are equal to dead people, not
Exactly.
not doing any computation things by their own, using the machines to the basic calculation as well. So it is because God has prepared the human as they are do as much as they can, because the brain has a capacity of millions of neurons it has, so it can process beyond the thinking of humans. Because when there is not that much evolved technology, the Wright brothers invent the aircraft.
Yeah.
So it is still there because they has a brain, they has a power of thinking. So if in nearby future or in later future that technology has been developed to be overpass humans, so I think so that is the more dangerous thing. As Elon Musk said, that more technology is also dangerous, because there is a certain limits for everything. More
Perfect.
than that limit is
Exactly.
everything is harmful.
Yeah. Very good. The touch of points, Vaibhav. I think it is a kind of real scenarios we are facing, and also it is well explained by Vaibhav. Thank you so much for the understanding and the particular points you touch upon here. Any other point?
Thank you so much, sir.
Or we can directly jump to that discussion topic, right? Okay. So I'll just touch some high level points on that next 1 minute, because I know it is not a discussion, but still, as Vaibhav mentioned that the technology, I believe that first you identify the need of technology. Forget about the smart computing system, forget about the advanced technology system, forget about that particular system itself. First to identify the real requirement. See, suppose you have a cell phone in the older version of, let's say iPhone 11, now iPhone 13, iPhone 15, then iPhone 17. So there is a requirement, or just like to sell to or to push to customers, we are going to sell it. Exactly. Suppose we have a kind of television. Television, maybe if you go to 5 years back, 10 years back, it was a kind of LCD, right? Sorry, LED. Now coming to also LCD, right? So my point is that if you look at the technology wise, what is the exact requirement? If there is no requirement at all, then the research development will not in a proper cycle to advance those things in terms of computation, in terms of the device, in terms of software, in terms of hardware, in terms of security, in terms of connection, in terms of sync up, in terms of storage, in terms of perception. Everything is there. So if you look at those aspects, I think there is some verticals need to understand by everybody whenever you are identifying the requirements. First of all, identify the convergence of intelligence and infrastructure. That is very, very important. You have solid ideas, you have solid requirements, you have solid, kind of well-defined the steps, what to develop, or why to develop, but you do not have the convergence ideas of intelligence and the infrastructure. That will be a kind of very critical then to take a advanced step on that angle. Second, hardware acceleration and heterogeneous computing. I'll touch up on those points through the use case of ADAS. And then third, software-defined intelligence. Because everywhere you look at this, that of course people are demanding a software system that may be AI aligned or non-AI aligned. Of course, there is a software system required. And similarly, if you look at the fourth, it kind of data-centric optimization. So that is also more important vertical in terms of smart computing or advanced technology. And then, as I mentioned that AI/ML model efficiency and sustainability. Why I'm putting those AI/ML? This is not part of AI/ML. Why I'm putting? Because nowadays, if you look at the current industry scenarios, even our companies we are in ADAS bracket, right? We are not outside ADAS. ADAS means autonomous driving. And there is a couple of departments. Maybe it is a kind of hardware, it's a kind of software, it's a kind of like security, it's manufacturing, it's a kind of testing, it's a kind of validation. A lot of departments are there, but still we are enabling, we are highlighting that the awareness of AI, impact of AI in their product line, in the departmental product line, how people will be more aligned towards AI/ML. That is called AI/ML efficiency and sustainability. To sustain how AI is going to impacting a very huge role in terms of the advanced technology. And then I'll go to the security and trust optimization. And then interoperability and standardization. That is very, very important. Interoperability, standardization. Interoperability means, suppose you have kind of tell me, how many of you know what is frugal engineering? What is the meaning of frugal engineering? You know what we know? What is engineering? We know what is reverse engineering, right? What is the meaning of frugal engineering? Okay, let me say very high level. So let's say you have a Apple i11 setup, right? Or you can say one handset. Let's say you are trying to purchase one Apple i17 version of the particular feature or the handset, right? Can we, without going to factory, without going to that particular production house, can we make it by ourselves with little bit of kind of engineering effort? Can we change that setup of handset of i11 to i17 in our home or in our lab? Can we do it? If do it, it's kind of called frugal engineering. Because you are changing some of your cameras versions, you're changing the camera pixel, you're changing your software, you're changing the battery, you're changing the security storage areas. So please stop me, because I cannot see whenever I am trying to share the screen. I cannot see those who want to put the questions, right? Please stop in between. If you need to discuss with me in particular point, I'll have to talk to you on that angle. Okay. And similarly, if you to try to do some kind of interoperability means changing those parts, because we do not know. Maybe you cannot change entirely. Let's say the particular motherboard of the handset, it is same. Let's say same, right? But you need to change the battery system, backup system, storage system, computing system, camera system, right? So those also need to change it, right? If you're changing those particular aspect of the advanced of a handset of iPhone, that is called interoperability, and you are making a kind of standardization, right? And of course, and the last one is called human system and co-optimization. Human system and co-optimization. I'll touch upon those particular point as well once I share my slide. So what is the human system? As I think Bible well said, the human system always is the supreme power of every technology, right? So Bible very rightly said that we do not need very much of advanced technology. People are thinking much on that side, right? Let's say we are trying to communicate with every device to device, edge computing, cloud computing, that we can say fog computing, everything is there. But did you ever think that can we collaborate with those computing systems? Can we collaborate? Can we sync up with those computing systems? My idea is that, let's say I have a company, right? I have set up productions, right? But can I communicate? Can my entire system of the company, because we are collaborating. See, let's say you imagine that you have your lab, you have kind of set up excellency in your college, right? Let's say set up excellency in terms of ADAS, right? You have certain parameters designed or well defined by your lab in charge or your lab spoke that this lab is meant for particular mission, vision, and objectives set by your lab spoke, right? Can you think on that? This is your first time lab happening in across India. A lot of labs also there, like this system, right? We are saying, in terms of collaboration, is a kind of very fancy talk. We're collaborating with IITs, we're collaborating with NITs, collaborating with lab universities across globe, right? But did you imagine that collaboration in terms of pen and paper, or in terms of computation? That is called the real world use case, or you can say human system, right? So if you do not identify those human system, how did you collaborate? Do you have some kind of that advanced the requirement to collaborate? Because your system connecting with that particular lab system, your infrastructure has to collaborate with their infrastructure. That is very, very important. Not that in pen and paper collaboration, not that in terms of writing mails or getting the kind of response in the chat, right? I'm saying collaboration means your entire lab system. Somehow you're managing collaborating, or you connecting with your system to their system through some kind of IP, right? It is fine. But my point is everything end to end, your lab need to collaborate with that, X, let's say your lab name. Y is another collaborative, another aspect of you, another space Y is there. Collaborating with X and Y means every features, every parameters of your lab, end-to-end collaboration should be there with your Y. If you think on that angle, you can see how it is important for all of us. So we are thinking on that angle when I try to cover those things in terms of ADAS use cases. Okay, so let me share my screen. Someone please confirm whether my screen visible.
Yes, sir.
Thank you, ma'am. So as I mentioned that it is a kind of the discussion should be on topic of optimizing. I will not be on those parts because my ADAS is the primary focus today discussion. I will not be on ADAS because I may not have expertise on that particular the domain. You ask me different domain, industrial automation, I can touch upon those points very few. But I'm not expert in everything. It is a very huge topic, optimizing next generation computing for smart system development. So I thought smart computing means I am trying to map those smart computing in terms of smart city. It will be my first slide. What is a smart city? Why is going to smart city? Then slowly I'll take you all together towards ADAS system, where we can enjoy those computation, enjoy those optimization, we can enjoy those system, what type of system it is, why it is called advanced requirement over there. This is very high level outlines. I'll already discuss that what next gen computing. I think Vaibhav and others already well said that it's a kind of requirement, well-defined requirement already set by those the research wing. And then I'll discuss on that software-defined vehicle ecosystem, what, why, and where. Software-defined vehicle verticals and features, and how AI/ML impact in intelligent software-defined vehicle, and some of the use cases in terms of AI solutions. Use case means in terms of parking, in terms of driving, in terms of in-cabin sensing, and then some of the opportunities and threats and Q&A. Perfect. So what is that, kind of on that the video. Okay, so if you look at this Intel video, I take it from the source, some internet source. So here I mentioned the critical concerns. Once you look at the Indian roads currently, but we are claiming it's a smart city, right? So actually I am from Bhubaneswar. So I am from Bhubaneswar. My native is Odisha. I am from Bhubaneswar. So our government of government of Odisha, government of India, we are saying it is a smart city. But still, we are unable to, prove ourselves it's a smart city, because smart city, a lot of concerns are there. Are those concerns already resolved? Still, it is open positions. There is some openings. There is some open kind of the huge bracket, and we are trying to fill those bracket, right? So if you look at on ADAS perspective, critical concerns are still it is there. Travel time. Then energy efficiency, environmental issues, accidents caused in human error, road infrastructure, and traffic control system. But still we are saying we are in a smart city, right? Not only we, if you put also very, very few countries across globe, those are claiming, and it is proved almost 95% accurate. Still, by namesake, we are saying we are really living in a smart city, right? So, but are you really smart on that particular aspect? Or still there is some openings, there is some advancement required. Every time if you look at some of the existing version of the product, we need advancement, but still we do not know what exact requirement. We are simply jumping towards advanced technology, advanced, mapping our mindset like that. We are trying to achieve those computations, but still it is not well defined to everybody. That's a huge concern. If you know everybody in terms of your institution, in terms of the industries, then it is a real collaboration among all the community, right? So I'll bring those parts slowly. If you look at this current challenge, I will try to define what is the software-defined vehicle ecosystem. I mentioned here pulsing the heart of the software-defined vehicle ecosystem, right? What is software-defined vehicle itself? Software-defined vehicle means why it's called software-defined. What is not called hardware-defined? There is no hardware. There is no ATAL computation happening. There is nothing, only software is there. So only software is going to manage the car. Of course, no. That's what. But the brain and the entire system is going to transform to software. Long back, it was a kind of mostly manual system, driver system. The driver will take all responsibilities to safely drive from one place A to B, right? But nowadays, the vehicle itself supporting the driver many aspects, like in terms of safety, in terms of perception, in terms of security, in terms of comfort, in terms of technology, in terms of, because you feel that nowadays software defined vehicle or the car or the vehicle itself a kind of gadget. People are you are using mobile phone, right? Everything is there. You are trying to make the system, the handset more handy in terms of everything, as if the entire globe within a fingerprint, right? Same thing, we are trying to develop those cars like a living kind of a living gadget, right? So that's what we are thinking is a kind of pulsing the heart of the software defined vehicle ecosystem. Okay. And intelligent software defined vehicle ecosystem, mostly there is a very common that whenever you're trying to develop the software defined vehicle ecosystem, we have some certain kind of layers, like the operating system is to be maintained, and the particular middleware system, some end user system, some of the some hardware system, some of the computation system. So there are a couple of layers in between in software defined vehicle ecosystem. I'll not touch on that point. It will take much time to discuss actually. Okay, so I even will not touch that part, software defined vehicle and how it is well designed, because if I talk on that, I'll be into the ADAS always. I'll not come out from this part. I cannot touch my the high level points I define in this agenda today. So I can very high level I can say software defined vehicle, that it mentioned clearly to all of you that automotive market and aftermarket. And car manufacturers are moving from hardware-based architecture to software-based architecture, a software-defined vehicle. So what is and why and where? It is a critical question. That's what the entire discussion of today's session start from that angle: what, why, and where. We are living in we are talking about advanced computing, talking about advanced technology, talking about optimization, talking about that infrastructure, talking about that kind of smart system. But are we really, we have the infrastructure? Are the system, suppose I'm talking about ADAS system, autonomous driving system. We feel that Indian roads nowadays is already well equipped, well designed to support the software defined vehicle. I don't think so. As a the developer, or as you can say the kind of the researchers in this software defined vehicle. So I feel even the softwares are failing very frequently whenever trying to to understand that Indian infrastructure, Indian road infrastructure. Then what type of competition is required over there? You think on that. Think. Bundle of questions for you as well. You think on that. What type of security system? What type of technology? What type of regulation? What type of the infrastructure? What type of synchronization is required? What type of optimization required? You think on that angle. Then you plan that, yes, now the thing which is a very, very highly demanding, the aspect of human, the humans are, identifying those gaps, and now those gaps will fill up by technology. Okay, so I'll show here. If you're coming from this discussion, I'll very quickly show you what type of autonomous system, autonomous driving system, what type of layers actually they have. Earlier, there is no automation. There is no automation. That completely depends upon the driver. Driver has to put all the effort. Has to put all the effort. Either how smart he is, that depends upon how smart driver it is, how smartly he is driving, how smartly he is riding, how smartly he is trying to do the mobility from A to B, a particular location, then or point A to point B. That is, we are simply saying, oh, we are safe because the driver was smart. But coming to the next line, down the line, there is a called driving assistant system. That is called level 1, driving assistant. Some driving, kind of modes here mentioned. Then number 2, level 2, called partial automation system. We are saying L0, L1, L2, level 2. Where in mostly L0, L1, L2, human driver monitors the road. Human driver monitors the road. Look at the particular aspect. Human driver monitors the road. But level 3, level 4, level 5, automated driving system, monitors the road. Right? So if you look at that angle, so here conditional automation, high automation, full automation, but theoretical aspect, you can search Google, you can identify those as well. There is no kind of magic over here that I am showing to you. You can simply identify, search in Google, you can find it, those very well defined. Even you can get a lot of materials. What is the automation driving levels? I will not touch that point. So I'll touch very high level. So please stop me if you, because once I share the screen, full screen, I cannot see your the comments or some particular the questions or anything or putting over chat. I cannot see. So please stop me in between. Either you want to speak to me, kind of through your mic, or you on your video. Speak to me. I'll stop my discussion. I'll completely jump to your point. Otherwise, allow me to continue. Thank you. Okay. Fine. So ADAS verticals. So here, the ADAS verticals are well designed by the IEEE. Sorry, the SA International. So they are already well designed. They designed that ADAS verticals in terms of the autonomous driving is a 5. One is the data engineering and orchestration. Second will be kind of sensors and the perception system. It may be fusion system. And then third one is that embedded software engineering. And the fourth one is simulation and validation. Last one is your functional safety and cyber security. Right. So what is the called of ADAS vertical? Why it is only 5? Why not it is a 6 or 7 or 10 or 3 or 1? Why it is 5? Because any software-defined vehicle or any ADAS system, it is completing the entire cycle of an end-user function. I'll come to the point. What is end-user function? End-user function means the function which is used by the end user, nav user, plane user, or a driver itself, called the end-user function. Because we do not know, the driver do not know anything on ADAS technology. How driver will know that technology? How the humans will know how the layman will know technology. They are simply user, right? So based on the end-user function, every end-user function has to touch upon those particular, the verticals of ADAS. Otherwise, they cannot understand the entire thing, how it is running, how it is going to be, integrated into a vehicle. So based on that, the SA International, that is the kind of standardization or the organization which is going to approve the standard of these L0, L1, L2, L3, L4, L5, which is going which particular the road is well infrastructure wise correct or perfect to adapt or to approve the L0 features in vehicle or L2 features in vehicle or L2 plus features in vehicle or L3, like that. That is a part of the SAE International. Similarly, there is also an organization called SAE India. Same thing also they are doing, part of SAE International. They are going to approve your vehicle when you're coming to run those vehicles or to launch those vehicles into the Indian roads with your specific end-user function. That has to be approved by SAE International or SAE India, right? And based on that, there is a well-defined 5 verticals. And the verticals are already, I explain one by one, very clearly I'll explain. So verticals are well interconnected. We cannot say, I cannot directly jump from, let's say, data engineering to directly cannot jump to embedded software. I cannot jump directly embedded software to functional safety. I have to follow these kind of the entire pipeline, right? It's a pipeline. Okay. So what is the driving feature scope? What type of driving features we have? A lot of features may come in future. A lot of features already we have seen in last 2 years, 3 years, last 5 years, last 10 years. But if you look at those features, couple of features, even to tomorrow there will be a bunch of features may come by researchers. There is a feature requirement need to be the vehicle need to adopt those features. The vehicle need to be equipped with these features, right? But we cannot say that this is the only those features, whatever I'm showing to you. But still, there is a kind of the segregation. We can say this is a kind of basic feature. Some of these standard features and prime features, you know that very well than me as well. When I'm going to purchase a car or two-wheeler or any particular that vehicle, that there is a particular version of the vehicle, right? We are saying this is a basic feature. So the particular cost is bit low. This is very basic, and there's some standard feature. The cost is than basic it is more, and the cost is huge if it is a prime feature, right? I believe this is also happening with everybody, right? So we should not think on that. Whenever we are trying to understand that what is the basic feature, what is the prime feature, what is your standard feature, so that is also designed by some particular organization, SA International and SA India as well. Similar also for I'll give some example in that driving feature aspect. Let's say adaptive cruise control. Most of us are having some car or the four-wheeler, and we know that some of the car also well enabled with the feature called adaptive cruise control, ACC. So and also ACC with steering assistant, emergency braking system, lane keeping assistant system, lane centering system. These lot of things are there, comes under basic feature. Some standard feature like tire pressure monitoring, surround view system, intelligent speed assistant, lot of things are there. And primary the prime features like rear cross traffic alert, driver drowsy detection, driver monitoring system, emergency driver assistant, or you can say intersection assistant. So and wrong way driving warning. These are called the prime feature or the very demanding feature or the costly feature. And also for parking feature scope, parking means we are looking to park our car automatically, right? So through this kind of software defined vehicle, we can park our car maybe in a parking place, nearby a parking zone when you are driving to a city, or maybe you want to park your car into inside your garage, maybe a public garage, sometimes also a private garage. So that is up to your requirement, but the car should assist, the car should support the some particular features when it is well aligned with software defined, right? And I just dividing the same thing also. So feature states like autonomous parking, autonomous driving. So with the autonomous parking, as I mentioned, like L1, L2, L3, L4. Also for in terms of your also parking like auto park valet, auto parking assistant, memory parking, surround view parking. So these are the kind of autonomous parking, autonomous driving. Okay. So this is again called that is called ADAS V cycle. What is ADAS V cycle? Why it is called V cycle? Looks like V cycle. It is a kind of B or something else in that V cycle. Why named it the V cycle? Those who are having some prior experience in the ADAS domain, please try to answer those questions, because I'll be really love to listen from you. I'll try to understand who are the faculty members working in ADAS the research field. You might have some kind of sync up required. You might have some kind of collaboration required. You might have some of the kind of alignment required in terms of data, in terms of understanding. So I'll be happy to connect with you after the session complete. Maybe you can ping me through my LinkedIn. So I love to try to understand your requirement. I love to also connect with you a different aspect of ADAS. So what is the V cycle? V cycle always kind of a end-to-end aspect of one feature need to be integrated into a vehicle. As I mentioned that there are a couple of verticals of ADAS. Similarly, when someone try to develop those features, this is the kind of entire development life cycle. You can say entire development life cycle. Not development means I'm not saying only software development. I'm saying feature development means starting from your kind of your architectural well-defined architecture. It may be hybrid architecture, it may be EV architecture, any architecture, right? So starting from that point, you combine those particular like the stages of your cycle, then coming slowly towards your vehicle homologation, or you can say that endurance test, right, or functional test. Endurance test means all type of states. How many states you have? You are trying to jumping from state to state. How your vehicle, how your system, trying to jump from one system to another system, one state to another state, right? I think that is called state diagram, right? So you might have those who are taking subject like I can say theory computation or automata theory. You might have seen that DFA system, NFA system from state 0 to state 1, right? State A to state B, right? Or you can say F0 to F1. I have maybe I've forgotten a lot of things on that. So when I'm going to jumping from a state to another state, of course we need some input. And the state A needs some input, and state B depends upon state A, means the state B requires the state A output, then state B can enable or function. Similarly, from state B kind of produce some output, the state C will take the processing, then it produces some state C. Finally, we are going to realize those outputs in the vehicle, right? This is a kind of state endurance test, or endurance system, coming from stage 1 to stage last. So this is a kind of those I'll not touch on, because this is very, very high level. Again, I'm saying I'll not touch those. If you'll touch at least one, not even 2, 3, then it can take almost an entire session to explain what is the vehicle architecture defining, why it's going to define hybrid system, why it is not EV system. If EV system, how it is well designed in terms of your distributed or centralized system. A lot of things are there. A lot of debates will be there, right? I'll not touch those points. I'll simply pass to show you very high level kind of what ADAS it is actually, right? And then ADAS perception system, right? So what is the hardware? I already explained what type of hardware we need to consider in ADAS perception system or software defined vehicle. But what is the perception? Perception means whenever you are going to how you can say, suppose you are driving your vehicle, right? And you are going to, because you are sitting in as a driver's seat, right? You cannot see the entire outside of the car. How you can see your back? How you can see your entire field of view of your left? How you can see entire field of view right? How you can see to entire the road condition? You cannot see everything by sitting. Some of things is very unknown to you, right? Some of things also very kind of very dynamic to you. Some of the things are static to you. You cannot say. But there is some sensor system which is working for you to assist to the driver in terms of a perception system. That's why I'm saying that the world environment we cannot identify, or we cannot see, we cannot visualize by sitting in driver place. That's why whenever you are trying to understand those aspects, this is called the ADAS perception system. How can you understand those aspects? Of course, there is some sensor fusion modality. So what sensor fusion it is required? Why it is required? What type of sensors are there? How actuation are happening? How data coming from a sensor to a particular vehicle, your computation system? How again after computation, how the outputs coming to your HMI system? By looking at the HMI system, how the vehicle control itself, or giving assistance to the driver to control the vehicle. So this entire system called perception system, right? So I'll not touch up again because see, I'm saying I'll touch up the use cases only, small use cases, but overall I can see the what is ADAS system. Then vehicle coordinate system. What is a vehicle coordinate system? Vehicle coordinate system in the sense it is very well defined over here also. Where to place the reference coordinate system? Imagine that you are driving a vehicle on the road surface, and the objects visible to you, right? Let's say it's a dynamic object, static object. It might be a static object. It might be a dynamic object. If it is a static object, if it is a dynamic object, that depends. That depends upon your requirement. Whether the dynamic objects may be a hazard for your, maybe a critical, or maybe kind of hazard for your safe driving, right? Similarly, the static object may be hazard for your safe driving on the road. Who knows, right? Let's say there is some kind of speed breaker, bumper, right? This is sometimes also called, sometimes also some of the signboards. Some of these are called the static objects. Some of the let's say the pathos. Some of please mute yourself. Kuldeep Pandey. Kuldeep Pandey, can you please? Thank you. Thank you. And dynamic system means, so whenever you are, there is a kind of object in terms of, always we have a x coordinate or y coordinate and z coordinate, right? So when we have some, the coordinate in terms of like the object. So we are, let's say your camera system. What a vehicle coordinate system means, where to place the reference coordinate frames. So started defining as a arbitrary point, and I mentioned here useful, now to formally locate these arbitrary point. So as I mentioned, there are a couple of sensor modality, maybe camera coordinate system, lidar coordinate system, your radar coordinate system. So maybe it is a kind of future coordinate system, you cannot say. So, but altogether, all the coordinate system has to align to world coordinate system, which is called the 3D plane, right? So that is called the vehicle coordinate system. The vehicle having, vehicle itself having a lot of, the system, camera system, radar system, lidar system, fusion system. So also vehicle itself having their own odometry, maybe your steering angle, also your speed, your position, your, the vehicle position, vehicle speed, your brake position, steering angle, everything is there, right? So those also called vehicle kind of, odometry or vehicle information, right? And also vehicle already integrated with a couple of your system, maybe camera system, radar system, also lidar system. So these systems all together is called vehicle system. The vehicle system has to coordinate with your world, means world coordinate system. That is called very, very important. Otherwise, you cannot drive smooth, and you may have some kind of hazards in between if you are going to fail to coordinate your vehicle in terms of your world coordinate system. And then coming to the very fast of the ADAS vertical, which is the mentioned data engineering and orchestration or management. What type of data we are going to store? What type of data we are going to capture? What type of data we're going to filter? Why we need to filter? What type of data we need to label or annotate? So those comes under the particular ADAS vertical called data engineering and management, right? So whenever we are trying to data collection, that depends on the requirement. If you have certain requirement, well-defined requirement, what type of end-user functions you are looking, what type of end-user functions you are trying to integrate into your vehicle. On that basis, you can set up your vehicle itself for data acquisition or data collection, right? There are a couple of stages like mass production, data-driven algorithm, cloud loop automation. So a couple of data collection phase, data annotation phase, data analytics phase, data ingestion phase, then model training phase, then test validation phase. So there are a couple of phases, but I'm not going to also explain all the phase. Very high level, you can say data engineering management means data is going to be collected, because unless we are not collecting data, we cannot understand that the entire computation because based on data. So what type of data you are gathering, or you are going to be collect. Based on that only you can train your model if it is a defined vehicle, and those model is going to accurately identify or satisfy the requirement which is well designed by the end user function, right? Data orchestration, cloud computing. If you are going to cloud platform, of course you have to follow some certain the steps like the ingestion, then analytics, then hot data, then cold data, right? So this is also not required for this discussion topic. I'll directly jump to that the computation part. Okay, this is important. Autonomous vehicle sensing system pipeline, right? So what is autonomous vehicle system sensing system pipeline? As I mentioned, assume that there are a couple of modality involved in your vehicle, like camera, lidar, radar, ultrasonic, like that. And then what is your next phase of your, like the pipeline? That is called perceive and localize, right? Until you are, assume that the data already, the sensor going to capture from outside your vehicle, and then, then passing to the next phase, perception and localization, where you could identify the lane detection, object detection, semantic segmentation, SLAM, SD map, all things are happening inside your perception and localization system. Then comes to the abstract part, which is called fusion, or you can say scene understanding, behavior understanding, predictions, map, right? That is in terms of your world coordinate system, how your scene going to be understood by the software-defined system. What type of behavior predictions and mapping those scenarios in terms of your software-defined system. That is more important. Then planning, driving policy based on driving policy or regulations, and path planning is more important. Maybe you can say trajectory planning. So these are the kind of the planning. And then control system. Once you understand that the situations is, let's say you are trying to control the vehicle by the vehicle itself or by the driver itself. So that is called, kind of control system. So steering to be controlled, acceleration need to be controlled, your brake to be controlled, either automatically or through your driver, right? So this is called end-to-end, autonomous vehicle sensing system pipeline. And then a lot of sensings are there, as I mentioned. A lot of the modality of the sensors are required to sense the entire outside of this entire of the vehicle. So the couple of sensor, they have own versions. Sensor, they have own limitations. They have the advantage. So that depends upon, again, it depends upon what type of the requirement you are setting, and also what type of sensor you have to choose for that requirement. Okay, and then video pipeline. So what is, imagine that suppose you have a particular video. Video in the sense you are going to capture through a image, right? So we are saying imager. Imager means the camera sensor itself. So video pipeline can be defined as a chain of interconnected components starting from video source to video sync. So this is also kind of your video pipeline human vision. There are couple of steps mentioned over here. Assume that there is a imager, camera system, right? And the camera system pass or to communicate with the SEDAS, the SEDAS system, the communication from imager to ECU. ECU means is a kind of SoC or the embedded board connected to the vehicle, right? Where the computations really have actual computations happening, right? So the imager and the camera has to send through some kind of canvas, communicate to your vehicle ECU, right? And then there is an image signal processor, raw image to usable image conversion and image quality function. That is a particular the function happening inside this CPU. And then again there is a GPU which is going to rendering your good to 3D and overlay. Some of the functions happening also through the GPU system, and an IQ control loop is there. And finally, that the vehicle bus coming from this GPU computation to vehicle bus passing to the encoder. Maybe there are kind of different encryptions happening, like the alternative options to compress or send rendered outputs. Then passing to the communication from ECU to the display unit called the HMI unit, or all different display units. So this is a kind of very raw steps where imagine that the vehicle having a camera system or an imager, then the vehicle aligned or integrated with one particular end user function, let's say ACC, advanced cruise control, right? So how it is processing through a camera system, and how it is helping, how it is the cycle is moving inside the vehicle, starting from input up to display the output to the customer or to the particular driver, right? This is called the procedure. Also, another called video pipeline computer vision. It was earlier called video pipeline, human vision, video pipeline computer vision. I do not want to explain what is the computer vision. I anticipate that the participants knows very well than me as well what is the computer vision system. So imagine that there is also same camera, one is a call of imager, and the communication happening from camera to your communication device, that is called ECU, through some some channel called the kind of maybe canvas, you can easily understand. And then same thing happening through your image signal processor called ISP. And ISP, nothing but a set of function where the raw image to usable, convert to usable version actually, right? Or you can say image quality functions. And then computer vision resizing. Computer vision means we are going to do some kind of downsampling, upsampling, everything happening also in that computer vision resizing procedure, right? Because we do not know the cameras, let's say what type of camera it is, what type of image resolutions it is, what type of field of view the camera have. And similar also that particular part, but the algorithm, it is designed in this, or it is already defined inside the vehicle, and the algorithm is meant to consume the exact input produced by the camera or not, or need to be also resized or kind of downsample, upsample like that, right? Because the feature maps need to generate from that model aligned to the particular feature map size. That's what we need to downsample or upsample during processing activities. That is called the CV resizing. And then CV algorithm through kind of CPU or GPU or hardware like that. And finally, the maneuvering system is this is a kind of your parking system. And finally, going to your vehicle bus. So this is I will not touch on that point. I'll simply yes. So whatever I explained, that these all together are called that how the generally one procedure or one flow of control starting from your sensor, maybe a camera system, and coming to your HMI system. Right, very high level. I have not yet touched more technical in-depth details because I thought to highlight those aspects of computation, how it is happening, and it's your job now. You identify what type of advanced things you can map it. What type of advancement required by looking at your research scope, by looking your research kind of depth, that how you can support or you can identify those gaps in terms of advanced technology for smart computing in terms of your either smart city or your smart campus, in terms of your smart lab, in terms of your kind of anything inside the smart, right, through ADAS. So these are the real questions to all of you, that if you find advanced things in that, the general idea I have given to you right now in this session, and this is up to you how you try to make your assumptions or the hypothesis more clarity, and you prove it that such assumptions may be in a reality that need to be adopted in your lab or need to be in your campus, in your college campus or institution campus. Okay, coming to that very important point here, that data augmentation on perception algorithm. As I mentioned in the previous slide, that if you look, as I mentioned, that is called CV resizing, right? Again, I'm saying that CV computation, CV algorithm computation. Why is having required? Because we generate feature maps, and the feature maps always some of the particular number which is going to be learned by your model or the computer vision model or the AI model, any particular, either it is a kind of machine learning or deep learning model, you need to learn it, right? So you are going to learn that those models by the particular feature map generated by your, the preprocessing stage. And then what type of augmentations is required? Why augmentation required? Because we do not have sufficient data. We do not have sufficient data. We cannot say we have covered during data capturing process of all scenarios we are looking for. Even that model need to be learn from different permutations and combinations of those images, right? That's what I'm saying. If you look at that, I'm not talking on that in details, because if I talk on, I do not know your background, what type of background you are. Maybe some of them, they do not know exactly what the feature map. What some of them do not know exactly what is the meaning of that, kind of the heat map to generate, why it need to be generated, how to identify those, the model, how much learn, how you change your learning parameters, how you change your hyperparameters, why you choose the particular, backbone of the model. A lot of things are there. I will not touch on that points. I'll touch on very high level that you imagine that, let's say you have an image and the image have some particular feature, and the picture has to learn by the model, and the model is already well tuned with some particular, some algorithm or some particular logic, right? Then say, let's say particular logic. But that is not sufficient to cover all those permutations, combinations of features, which is which is already passed to the model. So what to do? You are adopting some of the augmentation technique on perception algorithm side. That's what I'm saying here. The particular technique need to resample those particular those the features already sampled from your image, right? So that I'm saying there are different type of the technique, whether it is a kind of wrap technique or oversampling technique. So this is, if it is again wrap technique, they're called Cornell filters and colors or space transformations. If it is oversampling technique, called adversarial training, neural safety, then GAN data augmentations, a lot of things are there. But you can say very high level. People may be very familiar, those who are working in computer vision, AI, ML field of research, they know better than that me as well, that is a very common thing that for geometry transformations, we are doing some flipping, cropping, rotation, translation, noise injection. So those are very common for all of us, right? And apart from that, if you want to do some advanced things, you can check in Google, you can identify a lot of techniques behind that meta learning, like neural augmentation, auto augmentation, smart augmentation there. Okay, you can check it. People are not using some art, I do not know, but some art also very useful whenever you're going to identify your use case. Any questions, please? Already almost I discuss almost 45 minutes, more than that. Any question, please?
No, sir.
Okay, I was expecting some questions. I also need some break. I thought I will put some question, and now I will also get some break. I'll learn from you all. Okay, thank you. Thank you. So it is a virtual. I cannot do anything. So as a kind of a speaker, I cannot do anything. I always I try to to deliver my session, but I anticipate it should be a kind of two-way communication. But always I spoke to Dr. Sanjay Panda sir. So please make it ready that the participants should be interact with the speakers. Otherwise, it is too boring to talking to the customers, talking to the similar, because I am talking to customer means I'm talking to my faculty members. Always is a kind of one-way communication. Anyway, I'll manage it because I know that session has to be complete by another half an hour. But I request all of you, please put some questions. Even if you cannot put questions right now, frame the questions. Please search in Google, because you do not have time right now to put the questions, frame the questions. But understand the concept. Spend some time for your for your own. May not be for to showcase to outside. At least to understand what's happening surrounding you. Whatever background you have, I cannot say I don't care about your background. I don't care about your kind of the department you are actually in, right? Because nowadays, more than competition, it is more terms of collaboration. I believe in that. Nowadays, more than competition, we believe in more than collaboration. Because I struggle a lot during developing those particular AI stack, software stack. When I'm working day and night with my team, with my senior, with my junior, I'm learning from them every day. Still we are humble. Still we are looking to collaborate, because somewhat our technology, our advancement not sufficient to satisfy those requirements. So please, you spend some time in that. Don't think it's a kind of simple one FDP and you get a certificate all together completing the entire session. I request, once you learn those technologies, once you learn those terms, those particular that the cycle of these the advancement of ADAS, anything you are learning, not only ADAS I'm saying, maybe any topic, any domain. So spend some time and discuss with your students, discuss with your with your colleague, that can we make start with a small. Don't think to publish one paper, or let's say, because I was when I was in the faculty community, like you all that working as assistant professor once private engineering college, I was thinking to publish papers, satisfy management, getting some kind of salary hike, some kind of impression that people will know I have some publications, go for some patent, go for some kind of copyright. I thought like that time as well. right? So I changed the mindset. We need to develop a product, maybe very, very small product. You cannot complete the product even, right? Industry are there to really collaborate with you all. So I believe that if you start, and don't think that you simply have theoretically, to start and you got some, you're dreaming the idea and pitching to the investor. So can you please fund to my dream? Nobody can fund to your dream. People can fund the reality. People can fund. The investors can funding. You start funding to you once the investors see that you have some particular, that the outputs. Let's say they're building a POC and the 40%, 50% you already solved. Now the push up required. Then everybody will try to collaborate. Maybe I think nowadays Government of India is supporting some Idea Lab, right? Very, very good concept of Idea Lab. I had some of the old colleague they're sharing with me, like Idea Lab. Almost 1 crore or 2, I've forgotten the exact amount, 2 crore they are funding, right? What is the Idea Lab? It's a really good idea, right? Plan that. You enjoy those particular sessions which already delivered by the experts. I'm not expert. I'm not a very senior expert. People are there. They are very good in that in their domain, expert in that field. But when you try to understand those the technology or those advanced research in market, this is a kind of real platform through ATAL FDP or a particular any FDP. By sitting in your hometown, sitting in your lab, by sitting in your place or home, understanding those, I'm saying very fortunately, I'm saying your guides are very fortunate that even to understand this part, I struggled 2 years. I struggled 2 years, 3 years, 4 years. Maybe I struggled many times to learn those aspects. But I'm delivering to you only in 2 minutes or in 2 hours, right? Very beautiful collaboration between the Government of India with the institutes, those who are conducting these FDPs. But I'm sorry to say that when the faculties are just like taking it so silly, taking it so easy, spending your energy, you're spending your time, and I expect that at least put some question. Once you frame the questions, you understand many things. Anyway, so my job is to be complete those particular slides what I prepared today. But I request all the faculty members, starting maybe many of you are senior to me or junior to I do not know. But I request all of you, please put some time together and see the collaboration start here. Suppose you are talking to each faculty members over here, right? I'll be the kind of middleman, right? I do not know you, I do not know your colleague. But you start discussing with each other, the start collaboration point starts. You know that what faculty coming from which institute. You know that you are from which institute. What type of efforts you have to make it to the real collaboration. That's what I'm saying. Put question. This is not that put question to satisfy your ego or satisfy that you started putting questions to the speaker. My point of saying that once you start putting question, others will listen to you. They will answer to your question where I may not answer the question, but the colleague or your the other participant answer your question. And from that point, the collaboration point starts. Okay. So if you look at here, as I mentioned earlier stage, it was a kind of your algorithm kind of the stack. Starting from your data stack, then algo stack. Now coming to embedded software engineering stack. I'll know that even I'm saying if people are there in the industry, they are very depth knowledge than me in embedded software engineering. But I know a little bit because my job is to always working with a certain embedded computation device, not at all devices, because we are not the embedded manufacturing company or embedded associate manufacturing company. We have certain limitations. We have to use those already well manufactured embedded device. So we have to design our algorithm stack satisfying or to well align to this the computation system which is going to be integrated to your vehicle. That's what I'm saying. People are there. They have a lot of knowledge on that, but which I cannot explain to you in details. Even those who have a background, particular embedded computation, embedded software development, they even knows better than me as well, right? Okay. So very simple and high level. I'm saying again, long story in a short. So whenever you're going to train the model, that those model already trained in your kind of your GPU or CPU or your system, right? And those model need to be deployed into a certain hardware, tablet hardware. Hardware means is embedded SoC, or SoC you can say is a kind of your the embedded device, or you can say that your computation device, where the vehicle is going to compute certain algorithms, certain software algorithms, or software stack, right? And what is happening actually, whenever you are going to do some kind of the model training, let's say you got those model KPI or model output, model performance very robust, suppose robust output, right? So you are satisfied. By looking those model output, you are satisfied. We are saying, oh, really, it is good output. My detection, my classifications, my segmentation, my localization is very aligned to the the requirement which is set by the any XYZ customer, right? So that is the years. But whenever you're trying to deploy those particular algorithms into your embedded board, what challenges you have? Are you going to satisfy? Are you going to visualize those particular output, or the accuracy or the model performance in terms of your the metrics you set? Let's say precision, recall, F1 score, or whatever the metrics you are setting for your detection task or classification task. Are you saying that these are the very accurate things which is going to be identified or to achieve through your embedded device? I am saying, of course, it's a big no. Why it is a big no? Because I face a lot of challenges whenever we're developing those algorithms in your GPU and trying to deploy those algorithms into your embedded board, and anticipating those algorithms should perform running well in that embedded device, and that the robustness of the model has to be reflected on the embedded device. We are failing many times. Then what happening inside the embedded device? Why it is not going to replicate the same outputs in terms of GPU to embedded? So that I mentioned over here, machine learning experts build and train their network to solve their particular problem. And see, so this is not a kind of very the architectural view of all. This is a kind of your some Qualcomm device. I just took it from Google. I pasted it over here, right? This is not that kind of all those model, all those particular that SDK enabled with this all type of embedded device. This is a Qualcomm board, Qualcomm the SoC. Based on that, this is cycle. But the point is not a cycle, to understand a cycle. The point is what exactly, why you are not achieving those metrics, those performance, or the model, which is well structured, which is well trained, and the output is very really achieved in terms of your GPU system. But when it is it is going to deploy into your embedded device, the same performance is not achievable or not achieving. Because of that, the number of the algorithm means ultimately we have some, let's say, deep learning algorithm, right? And what we have certain the optimizer, certain loss function, certain parameters, certain activation function, certain convolution operations, right? We have certain kind of like the input, the feature size, right? So similarly, whenever you are talking to an embedded system, that the embedded system is aligned to the same loss function, supporting those loss function, which is already we trained during your GPU computation, right? Just I'm saying one example. So such things also we need lot of the efforts. Let's say your model trained into particular GPU, which is a kind of the decimal, right? And to convert the model conversion required, or quantization, model conversion required. So model conversion required, then model fine-tuning required, then also kind of the model optimization required, then the the model evaluation required, right? So lot of operations need to be to adjust in embedded system. We cannot say simply you get those your algorithm in terms of your .pth file or in terms of your .onx file, and simply deploying to your the hardware means it is going to be get the same output as like the computer may not get. We have to adjust, because the target MMA, the target APS, the target the GMAC, the target runtime, everything will be aligned as per those the hardware. I think someone can you listen me?
Yes, sir.
Am I audible?
Yes, sir.
Thank you. Okay. Okay. So this is called. So the question is here. Question is not that for that how embedded system is happening. The question is here how AI is impacting. I thought you will put the question to me as well. How AI is impacting over here. And why is it, why it is AI is a kind of coming to the picture, because this is not an AI topic, but why I'm mentioning that AI is impacting, because I'm saying that AI ML algorithm need to be developed, and AI is the real kind of trend to to take you from the advanced technology. Real trend to take you to advanced technology, right? Earlier, to design I'll take some kind of different examples, not ADAS example. Earlier, suppose I am trying to design one kind of like the histogram plot or bar chart or pie chart or box plot or any statistical kind of statistical analysis of my data. What do you need to do? I believe in that. When during my PhD time, I use a lot of kind of tool like Reliance Soft, maybe kind of MATLAB, or let's say you are using a kind of different type of softwares I use. I forgot the names as well. So that time I used to design those plots itself, right? This is a CSV file data, and I'm trying to plot some histogram diagram. Or because some Excel, we are saying Excel, sometimes also Excel is not sufficient. So that's why I took some kind of help of some tools, right? But the point is now, if you look at the advancement, you can simply speak to ChatGPT, pass it to your Excel data, speak to ChatGPT within a 2 second, 3 second, maximum 5 seconds, you can get all the analysis in your hand, right? So this is called, that's what I'm saying. If AI is doing everything, can we do it? Can something impacting such kind of adjustment in terms of hardware, in terms of kind of the core of embedded system, where the metrics or the performance is not aligned in terms of GPU to embedded board? How AI is going to impact over here? How is going to be playing a very vital role over here? That complete question to all the participants. Please search how AI is going to be impacting the embedded software engineering, and how AI is going to, because now people are saying embedded AI. People are saying embedded AI. We are saying quantum AI, right? So quantum is something different, but I'm saying embedded AI means how AI is impacting embedded system. That is more critical. Very, very critical. Not saying very, very critical. Even I do not know much. I'm sorry, I even do not know much on that side. Okay, so embedded system and AI. So if you look at that same, as I mentioned in the previous slide, that so like general the purpose processor, example CPU, and then hardware accelerator. We have some graphics processing unit, GPU, AI accelerator, example vision processing unit, and tensor processing unit, TPU, data processing unit, DPU. This is a very high level, I'm saying, very, very high level. Just like a standard one student can also understand what is GPU, what is CPU, what is TPU. But this is our job to understand the mapping it. Now, prototyping those particular platform. Prototype means whenever you're prototyping those platform in terms of GPU, in terms of your TPU, in terms of your DPU, how the hardware accelerated, kind of playing a vital role in between those computations. Right. So embedded system, I will not touch upon embedded system much, because this is not the time to discuss all those particular aspects. It's almost, I think, 6:20. I will just high level. I can say there are some programmable board, and there is some kind of the single board computers. There is some workstations. So this is a very, very high level kind of the diagram. I took it over here from internet to explain you software and hardware specific boards, single task specialized system, some real-time computing system, and also in terms of your workstations, how multitask system is happening, how in the run or large set of hardware is going to be adopted, and then comparison. Anyway, it is very theoretical, not required comparison. You can leave it the part. This is a kind of simple NVIDIA Jetson, the board, how it is working for our ADAS system. Anyway, you just forget on that. It's not required. Okay, this is also required. Simulation and validation. Imagine that I spoke about now three things. First of all, I spoke about the data orchestration and management. I spoke about that perception, or you can say fusion system. I spoke about embedded software engineering. Now I'm talking 2 years, simulation and validation. So if you look at simulation and validation, why it is required? Tell me frankly, those who are working in any particular project, maybe a student project, maybe your R&D project, maybe your funded project, maybe your collaborative project, maybe your kind of a private body project, or maybe a POC.
It saves cost before doing anything and see what happens. Based on that, we can design our.
Sorry, ma'am, continue. I think you are breaking some voice.
Am I audible now?
Yes, ma'am. Yes, please continue.
Simulation is very much required in order to make the in order to reduce the cost, because everything we cannot go and directly do it on the system itself, because it takes much cost. If we can simulate by means of softwares and see what happens if we give that input or so, then it will be easier for us to design a system. So in order to save the cost as well as to make it simpler, we are simulating it.
Well said. Thank you so much. Well said. Yeah. And I see that that the particular answer. I'll see your name, ma'am. Your name, ma'am.
Sir, my name is Umayal.
Umayal, ma'am. Thank you so much, Umayal, ma'am. It's a real kind of the aspect of the simulation. Why you are going to simulate and validate your model. So as I mentioned that it's a part of your our ADAS system. So this is your core vertical. So whenever you imagine that the model already embedded side we deployed and the model outputs you can achieve in terms of your embedded performance. And let's say classification task, detection task, segmentation task, everything we are achieving. But the point is that, as Umay ma'am said, that we have to identify the scenarios. All the scenarios may not be the model come across, but we have to test, simulate. You have to simulate. So this is after something called seal, and here called peel, here called wheel. What is your seal? System integration test, right? So you can say peel and wheel integration test. So these are the testing. It's the particular seal pipeline, hardware in loop, system in loop, software in loop, vehicle in loop. So these are called the seal, heel, peel. A lot of things are there. So a lot of people are the renaming. This is depends upon your requirement. You can rename it, right? But altogether, as ma'am said, that simulation required to identify those scenarios where the model will not come across, and even come across the performance. Actually, we are not going to test without simulating your model directly on the road, right? We have to simulate those particular software which is already inbuilt into the hardware, into your SoC or the embedded board, and the performance are tested on embedded side, but not in your simulation side. The performance has to be tested. There is a certain kind of test scenarios, right? Scenario 1, 2, scenario. Let's say you have defined scenario 1, 2, 3, 4, 5. Suppose to satisfying the individual function, let's say ACC. ACC means advanced cruise control, right? And where scenarios 1, 2, 3, 4, 5, you cannot create a scene. You cannot create. You cannot run your vehicle on the road to come across some scenarios. We have to identify. We have to create synthetically those scenarios. Scenario 1, 2, 3, 4, 5. and test your vehicle performance in terms of those algorithms already designed, already deployed in your hardware. That is called, and also you have some entire pipeline ready. There is some activation logic to be ready. There is some kind of the features when you are going to be to pass to your model, that everything need to be aligned with pipeline, right? This is called a seal pipeline, because to satisfying the criteria you would put together the software to become across criteria 1, 2, 3, or scenario 1, 2, 3, 4, 5. That is called seal testing, right? I'll not explain much. I'm not also expert on that seal pipe. Just I'm giving some kind, because my role complete developing the AI algorithms. I'll much talk on that side, not on that entire simulation. A lot of things are there. Those who are really good on that part, they can explain you better than me as well, right? And coming to that kind of the hill, like the software environment, hardware in loop, also the vehicle in loop, and validation. You have validate the end user function, validate your certain parameters which is well structured before you test your vehicle. Big question here that how AI is impacting, right? So similarly, those who are doing the human beings doing it manual, sometimes simulation is doing manually, create the scene synthetically, and also testing manually. So there is some kind of AI enabled system which should be automatically identify those scenarios which need to be tested by your vehicle, which need to be kind of validated by your vehicle through AI. So whenever your automation need to be happen, we need the support of AI. I believe in that. People are also working on that side, how AI is going to be impact on your now in simulation validation aspect as well. And I think at the time already almost time complete. 2 minutes remaining. I will not complete those slides, I know. So simply I jump to the Q&A session. So if you have any questions, please put. Yeah. I hope 160, 161. Though this is going to complete by 2 minutes, people will join to give the attention to your coordinator that we attend. Okay. So why I can understand your mindset, because I was working as a faculty also as well during my lectureship time. I know that particular the thoughts. So please come out from that thoughts. Please, I'm requesting all of you, please think that it's a well structured FDP session, and you learn many things from this, and try to understand the requirement. Any question? I don't think. Sanjay sir,
No, sir.
no question, right?
No questions, sir.
Thank you, Dr. Aksan.
Myself, Dr. Kakishan.
Okay, thank you. Sorry, your naming your name. Okay.
No, not at all, sir. Thank you so much.
Yeah, thank you, Dr. Satyajit, for your nice session and motivation from both academic as well as industry side. So I'll share the email ID of Dr. Satyajit Nayak. If anybody wants to contact related to ADAS, that is a very new topic, and all the technologies are integrated into that particular field. So you can contact him for any lecture or any of your doubt. So thank you very much for joining this session.
Thank you, Dr. Sanjay. Thank you.